In this video, we're going to explore one of the most important parts of any synthesizer, the oscillator. Oscillators generate the raw sound that you'll shape and manipulate using other parts of the synth. Understanding how oscillators work and how different waveforms sound is key to creating unique sounds. Let's start with the basics. What is an oscillator? An oscillator is a part of the synthesizer that generates waveforms, which are the building blocks of sound. These waveforms are essentially repeating patterns of vibration, and they determine the pitch, timbre, and overall character of the sound. As we said before, in Vital, you can choose up to 3 oscillators, and you can blend them together for richer textures. Let's go over basic shapes, which you can find in the All section at the very top. This is the sine wave. The sine wave is the simplest waveform. It only has one fundamental frequency, which means it sounds very pure and smooth, like a whistle or a basic tone. It's also what you're going to use to create sub-bass, because it doesn't have any harmonics. You'll know a sine wave when you hear one because it sounds smooth and soft. No extra buzz or noise. This is a saw wave. The saw wave has a very sharp and jagged shape. It's rich in harmonics, which make it sound bright and buzzy. Saw waves are often used for leads, basses, and pads because they cut through the mix easily. You can instantly hear how much brighter and more aggressive it sounds compared to the sine wave. This is a square wave. The square wave has a blocky, on-off type of shape. It has a hollow, almost robotic sound because it contains only odd harmonics. Square waves are great for chiptune sounds, leads, and bass lines. Notice how it has a more metallic, hollow quality compared to the saw wave. Lastly, we have a triangle wave. A triangle wave is similar to the sine wave, but it has a bit more harmonic content. It sounds slightly rougher and is often used for soft pads or leads. Triangle kind of sounds like a blend of all the basic shapes together. All right, we've covered basic shapes. Let's talk about wavetables. In addition to basic waveforms, Vital uses a more advanced type of synthesis called wavetable synthesis. A wavetable is essentially a collection of waveforms that you can morph between to create evolving dynamic sounds. In Vital, you can load different wavetables into the oscillator and use the wavetable position slider to move between different waveforms. This allows you to create more complex, evolving sounds that change over time. Let's select a wavetable. Drink the juice. Let's scan through the wavetable. Ooh, that's a good one. If we create a ramp with an LFO and then drag it onto the wavetable position, this should create some sort of wobbling effect as we scan through the wavetable. You can drag this circle around to determine how much of the wavetable is being scanned through. Pro tip, only scan through about a quarter at a time. Then move the wavetable slider. In my experience, if you scan through the entire wavetable position, you get something that's a little messy. Remember that we'll be adding a lot of effects after this, and the more simple our input signal, the better. Now that we know the different types of waveforms, let's look at the controls available for each oscillator in Vital. These controls allow you to further shape the sound generated by the waveform. In the top left, we have pitch. You can turn this up and down by semitones. 12 is an octave. Or you can move by cents to fine-tune it. 100 cents is 1 semitone. The level slider controls the volume of the oscillator. You can use this to balance multiple oscillators or fade one oscillator in and out. The easiest way to make something wobble is to use an LFO on the level. We'll start with the level all the way closed, and then bring our modulation amount all the way up. Now our patch will wobble based off this frequency. You can imagine that using this one LFO, automating the level as well as the wavetable position, will create some unique results. Let's move to unison. Unison is a way to thicken the sound by detuning multiple copies of the same waveform. 1V means one voice. If we increase the voices, we're increasing the instances that are being played. If this is at 7, then we have 7 exact copies of this wavetable being played at any given time. The number to the right here is the amount of detuning that's happening. As we increase the detune, it becomes less and less tonal. Let's talk about frequency modulation, or FM. We can select that with the 3 dots here, go to FM from oscillator 2. FM is the process of using one oscillator to modulate the frequency of another, creating more complex harmonic textures. This is great for creating metallic or bell-like sounds. To activate this, we need a second oscillator. It's taking the FM from oscillator 2, so this needs to be on. The most important part about using FM, the oscillator that you're taking the FM from should have no level. Now this knob is just a dry wet. How much FM are you sending? Make sure to experiment with different octaves in oscillator 2 when you're doing this. That's the basics of oscillators and waveforms. I'll see you in the next video.